the improvement that we have done this year in Bloc. I start or?
Yes, you can start.
Okay. A little about the improvements that we have for again, we are with Martin. We are both engineers of the Pharo consortium. You have our contact details. That's good if you later want to ping us. Okay, just a little reminder. What is Bloc? Bloc, it's our, let's call it graphic stack, because it has many layers, it has many pieces that interact with each other. We have a Bloc that is the core graphic framework, but on top of that, we have a widget set, a rich widget set that is Toplo, integration between Toplo and Spec. T2 we are going to talk tomorrow more, so if you are interested on how to build applications on top of Toplo, on top of Bloc, is a good point. Then we have two components that are more based, that is Alexandria, that are the bindings with Cairo, that give us access to low-level operations. It's implemented to be as fast as possible. It's the simplest FFI calls. We try to simplify in the sense that we try to minimize the impact of time. It has its complexity to use. It's not intended to be used directly, but if you want to use raw Cairo for an application that requires it, you can have Alexandria on top of it. Then we have Album, that is our text editor, that per se it's implemented on top of Toplo, but it's complex and has a lot of features, so it's its own project apart. So here we have a lot of movement. It's not only us with Martin, there are more people, then we are going to talk about that, but we have a lot of movement. For example, we have in the total of all the projects, we have more than 1,300 commits distributed in all the parts of the framework, all the part of the stack. As you see, Bloc and Alexandria are getting less because they are getting more and more mature. But what we are going to do more this year and the following years is to continue doing more on the side of Toplo and Album and Spec Toplo, so we can build things on top of Bloc and Alexandria. There are a lot of fixes and improvements in Bloc in the last year. Some are really specific because there were bugs. Bloc is usable since a couple of versions. We are using it. People are building applications on top of it. They are going to production. They are happy with it. But we have bugs and we are fixing and improving things. Especially we are working a lot in an alignment of the API, so making it more nicer, more consistent in the whole system, and consistent also with the nomenclature and the idiomatics that we use in Pharo. We have cleaned it a lot. We are doing housekeeping a lot. For example, we are migrating all the deprecating methods. We are starting to remove them because the idea of the deprecation is that eventually to remove it, not to keep older versions forever and ever. And we are improving a lot of the elements that are behind the scenes of Bloc, especially all the algorithms that are performing for traversing the different elements. Bloc as morphic is a really rich. You will create your visual components like with rich objects that you will add a lot of component, a lot of behavior, and you will distribute your behavior, and you will create a lot of objects. So that's good because it's easy to use, but from the point of rendering, it could be a nightmare. So we have to improve these traversals of objects and it's a handling of the life cycle. I didn't enter too much in the details what we have done because there is all the changes, the change state of the versions that we are releasing regularly. But I want to show what are the main features. One of the big features is that we integrated what we have presented in the previous presentation. We are integrating it slowly nowadays. We have the idea is that we introduce SDL3 as an alternative to SDL2 that was already present in the image, in Pharo image, and we are going to use it not only in Bloc but also in the morphic world until we habit it, or until we remove eventually morphic, but we are going to profit about having SDL3. What we have done, but a lot of work of Martin, is to implement a backend for OS window for SDL3. So there is basically a transparent transformation from one version to the other. We are using most of the features in a common way. What has changed, it's adapted in the new driver. But basically, for the users, in this case, for Bloc and Morphic, is completely transparent. If we see the architecture specific for Bloc, what we have done is now we have a new host, a Bloc host. The Bloc host is the component in Bloc, the layer in Bloc that is the one that provides the events and handles the rendering of the elements, of the PL elements. Basically, this is a transparent solution. We have worked a lot to have a transparent solution based on the integration and on the abstraction that OS Windows give us. So it from the side of the user of OS Windows, it's completely transparent. If you were using SDL directly, it's not transparent because it had changed. But it's a lot of, let's say, a lot of magic that especially Martin has thrown into the equation. So we have something nice that has fixed in SDL3, and we are profiting it, and that is that we can have a better handling of background processes. And Martin, do you want to tell us?
Okay.
Yes.
Go to next, please. The slide. So yes, to tell what is this, I tell you about a small experiment in the computer. It's a morph that changes color on each step. It steps every 60 times per second. So this is 16 milliseconds approximately for frame, and each frame changes from blue to orange, no? And at the same time, while this morph is changing, we have a background counter that it sums increases in one a counter. No, but it is running in a process that has lower priority than the UI. So it has the UI, the morph will be in priority 40 and the other 50. And go to next, please. So I don't know if you appreciate it, but this is to show you that what is the screen tearing in. I don't know if I don't see it well, but well, here I got an FLA. When you change here, maybe I see it, but the video stops too fast. Well, what happens is that if there is something called vertical sync, and it is traditional in the screens and in the video cards. And when you use the vertical sync on, you wait that the screen scans with the current content of the window of the screen, and then you change the content in a moment where it is not in the middle of the scan. No? And when you do this, you don't see this. What we have here is what happens when you have turned off the vertical sync, because if you cannot control it, it works like concurrently. There is a video card updating the screen, or the screen updating itself, and you change the contents of the screen in the middle of the scan of the monitor. You will see weird effect of the previous frame and the new frame, well, like that. So go to it. And what happens in Pharo in particular, and with the experiment that I mentioned before, is that sometimes in the worst, the bad cases, I know in some I didn't observe it in, like in Windows, in my Windows computer, this didn't happen. In my Mac, it happens. I know. Yeah. What can happen is that you have the processes, the Pharo processes in execution. For example, here you have the top priority is reading or processing the events, like the key pressed or the mouse moves from the system. This in general is fast. You consume the effects and then enqueue actions. I know. For example, in here it represents a process that is rendering, it taking a lot of time, or this time to render the orange, and then it sends the at some point it ends the new frame and sends it to the screen. And when we have SDL2 or well, we have vertical sync on in some particular situations, this happens that the process, the Pharo, the operating system that runs Pharo stops until it's blocked, until the cycle of the monitor can accept the update, and then you can continue. For us, it is transparent, but we can only see that something going slow or like now the red the background counter is crying because it is never executed, because when when Pharo continues its execution, there is something with more priority to be executed, and then so when you turn vertical sync off, this is much better for the background process, because you will see screen tearing, but the process counts. The background process has time to execute. So, and good news in the SDL binding is that we have more API, more options to play with this with mixed solution. We are doing more. We have this OS window driver that has the CPU in the middle. We are providing two new drivers. One for SDL3, but like a standard, like the previous the current SDL2 driver. That and also another driver for more experimental, using the new CPU API of SDL3, and we could do in this case like this to do not freeze the Pharo execution. You send the new frame, and if it is not possible to update yet, it does not block the process and can execute. So there are some settings that we added to play with this. If you load the project of the previous talk, this OS window SDL3 package comes with it, and there are instructions you can enable it and play with the parameters. So that's it. You continue, you are mute, Pablo.
Oh. Thank you. Now we can talk a little more about the roadmap and the ideas that we have.
Pablo, I'm sorry, I will just tell you, because normally you have 2 more minutes. We will give you 5 extra minutes and go into the coffee break. But just that you know,
it will be good.
Yeah.
Okay. What do we have? What are the point that allows or to restrict us now in doing applications with Bloc and doing applications that we want to refresh and have really interactive applications? But basically, we are limited by the fact that Pharo code runs in a single OS thread. That is like this, and this is other limitation that we can talk for other day, but we have this limitation from the point of view of writing applications in Bloc. We can do tricks like we were doing with playing with the the new ways of handling the synchronization, so the background process will have time, but we are always limited, we will always get into a problem. Basically, what we are having now is that when we are drawing something with Cairo, with drawing something with Athens or Alexandria or whatever that we are using, that has to run in the single OS thread. Depending even in the operating system, it has to even run in the main thread. That produces that we can have a starvation of the other Pharo processes, or that we don't have time to run something else than animation. So what is the solution, or what is the path we want to walk by to explore, is to offload this workload, the drawing workload, to a separate thread, OS thread, or a separate process. So to keep the UI responsive and keep the application responsive, the background processes responsive also. So we are doing a step by step to arrive to this. The first thing that we want to do is to have an asynchronous rendering of the graphic elements. For doing that, we have added a mutable DOM behind the block elements, something that is not used by the users, but by the drawing process. The drawing process will keep updated this mutable DOM that register changes and is completely independent of the BL elements. So you can continue creating your elements as you wish, and then the drawing process will create a representation of these graphic elements in the primitives that are expected by, in this case, by Cairo, but also the primitives that are expected by SDL. The idea is that we can have this rendered in an asynchronous plugin, as it is a more simpler data structure. It's basically a data structure what we are generating. We can implement it as a VM plugin that will perform the rendering in a separate OS thread, and can have this rendering at the same time that we can continue drawing and doing Pharo stuff. We can continue doing something else in the Pharo side, because we are liberating the Pharo thread to do this rendering. For doing so, we have to validate that we are doing the same, because one of the problems that we have is that a graphic framework is not easy to test. For doing that, we have added a lot of regression tests and benchmarks, and especially a stress test that we want to see that the new solution is better than the old one in many sense. Also, we have been using mutation testing, or we are using, and we'll continue using mutation testing to find difference, to find errors, and to find performance issues. You can check the talk of Fede in the IWST if you are, because this is a really cool application of mutation testing, and we are using a lot, and we are finding issues and fixing them. What are the next steps? The idea is that, okay, we have now a component, or we are maturing a component that can render the same that we render from the Pharo side, but in a parallel, in a sync way. The idea is that we want to profit the layering of the applications. All the applications that we are doing, even if you are doing really interactive application games, doesn't matter. You are not drawing all the time, or you are not changing all the UI, all the windows at the same time. So you are changing a small part. For doing that, we can profit and divide the windows in different layers and render them separately. And then we can use the composition logic that we can run through SDL in the GPU. So the composition logic will be really fast. This is the way that graphic applications, especially web browsers, are working now, and they are going this way because it's the only way that makes it possible to scale. And we want to separate the application logic and the rendering in different processes. This is even a later state where we want to differentiate, really having multiple OS threads or multiple OS processes. The future, where we are going there? Well, we are working on this concurrent rendering. This is what we are talking. We want to validate, work a lot in this new architecture, but also we have to modify how the components in Pablo and Bloc are done, so they profit, for example, of the layering. In the meantime, we are working a lot on adding new widgets of top load so we can create more and more rich applications. We are doing a lot of work in albums, so we can have even richer applications that can edit text, and even the idea of this is that we want to eat our own food and have Pharo running in Toplo and work. And for this, if you are interested in all the widgets and all the things, and even what we are doing to run Pharo on top of Bloc and Toplo, you can check the presentation that we have tomorrow. This work is not only from us. There is a lot of people. We cannot make 1,400, around 1,400 commits or fixes with you only. So this is a lot of work, especially from the side of Alan Plantec or Benoit that is there. You can say thank you, Benoit. Stefan is pushing a lot. And also we have a lot of help of Enzo that has been working with us for improving Bloc, with Cyril and Chris, and they have worked a lot. And it's really nice that we have a lot of contribution. And as you see, there is people from a lot of places, and they are contributing a lot to improve Bloc and to improve Toplo and all the little components that we have around.
Thank you, Pablo.
So thank you so much. These are all the contacts that you can have. You can contact us. There is documentation. I didn't enter because I enter all the time on that. We have documentation. We have books. We have example how to use Pharo, how to use Bloc and Spec and Toplo, and how you can use it then too. So we are releasing all the time a new version. The idea is to have every 2 months new versions. So you can check there the released versions because they have the changes and all the information. Thank you so much.